Our first speaker for today is Bastian Greshake Tzovaras. Bastian has a PhD in bioinformatics and he's a co-founder of the Open SMP, and he is the director of research at the Open Humans Foundation. In his talk, Bastian will share his experiences in making data open and maintaining it.
Great. So good that everyone is still awake even after 3 days of being here so early. And I want to talk a bit about how to share data, why sharing data, and like limitations of how to share data, a bit along the lines of what we discussed yesterday during the panel discussion about privacy issues. So first of all, why sharing data? And sharing data these days is basically as important as making your code available. Because in many cases, just sharing your code isn't really useful if you can't get access to the data sets that people have used. And here's one example of the deep learning era and the importance of data. Is like they find that the performance on vision tasks increases logarithmically based on the volume of training data size. So basically, the more data you have, the better you can actually do whatever you would like to classify. And it's not only that you need lots of data for doing these deep learning vision tasks. And in genomics, which is my field more, it's the same thing. So here's a nice paper that came out this year where they used 1.1 million human genomes at the end of the day to find out whether there's some correlation between genetic variants and educational attainment. So how well do people do when they try to get education? So the too long didn't read as data is pretty cool, and that's why we want to have lots of data and want to get as many data as we can get, but this means we need to share it. But the question is, how does this now relate to reproducibility? And reproducibility we talked about yesterday, but it's not like a single thing. There's like this whole matrix of what we think of as reproducibility. So if we look at like the same data sets and use the same methods, this is reproducibility, and that's like the easiest and most basic kind of reproducibility, or like of these 4 things you can achieve, because it basically allows you to do this. It answers the questions, does this data and method combination do what people claim it's actually doing? It's like the minimum requirement that you usually want to do. Just figure out whether this actually achieves what other people have said it does. Then if we look at using different data sets but the same methods, we get to replicability, which is, was the previous data maybe just somehow weird, and this is why the method performed this way, or is like a different data set collected independently giving the same answer? And then we have the issue of robustness, which is looking at the same data set using a different method and seeing whether we can still find the signal we originally found using the first code. And last but not least is the generalizability, whether multiple methods and multiple data sets all agree on a single answer. And this is what we as researchers and scientists usually are interested in, generating generalizable knowledge, which will be basically what we assume to be true. So this is what we ultimately want to get to, right? We don't want to just reproduce things. We actually want to get generalizable knowledge that is useful in a much larger scale than just reproducing things one-to-one. And how do we get there? Well, for getting there, there's no shortcut, but we need to go through actually all of these. So you start out by reproducing things, then you try to replicate it with a different data set. You try to see whether a different method still gives you the same answer. And by doing all of these 3 things, only then you basically get to really generalizable knowledge. And for this, you need to, as I said, do both, because otherwise you have a really big problem. If you can't do this, if you can't get access to the code or you can't get access to the data, you can't perform all of these 3 things, and you're basically stuck, or you need much more time because you need to first replicate and reproduce your own data all the time. So the issue is, if you have not the data, you can't reproduce, you can't test the robustness of new methods because you can never see data because you can't use different methods on it. And as a secondary effect, the replication gets much harder too, because you have never really certainty whether the original method even did what it was supposed to do. If you just get the code and you never know whether it was actually run in the way people say it was run, you spend a lot of time trying to figure this out as well. And it means basically you need to collect twice as many data because you basically need to reproduce yourself first. And that's always much more work than it should be. So the solution for this is share your data and then everyone get access to it, and everyone is like very happy because they save a lot of time. So the issue is when it comes to the reality. It's like a nice idea of sharing data, but unfortunately that's not always the case. And here's a paper published in May this year where they analyzed the data availability in PLOS ONE, the journal. And PLOS ONE has like this data availability statements And they basically made like a guideline that data needs to be accessible, or at least needs to be shared if people ask for it. And they looked at nearly 50,000 papers published between March 2014 and May 2016, so 2 years of data. And they wanted to look whether the data availability is somehow given, and they find that only 20% of the statements include any reference to a data repository. So 80% of the paper and plus one, the data is not in a repository that you can easily find it. And then you can say, okay, maybe people say we can make the data available upon request, which is somehow what many people say. They don't bother putting it somewhere. They just say, you can ask us and we'll give it to you. And also this year was published a study on whether people are actually willing to give you the data when they say, we will make data available upon request. This was published in PNAS, I think, and they looked at 200 whatever papers published in Science, and Science says you need to make the data available upon request. And when they actually looked into it, unfortunately, it's turned out that just saying you need to do it doesn't really work out so well, because what they found is that they could only get data for 44% of the people they asked to and could replicate, reproduce 26% of the findings published in Science. So 75% of people basically did not share their data in a way that people could reproduce it. And if you look at why people were not willing to share their data, so they emailed these authors individually and said we would like to get access to the data of this publication, as you said you would give us access to for replicating it or producing it. And this is what people say. So they say, oh, when you approach a PI for the source codes and raw data, you better explain who you are, who you work for, why you need the data, and what you are going to do with it. So not the most friendly answer you can imagine if you get an email like this. Or it's like a very unusual request without any explanation. Send me a detailed, and I mean detailed explanation of what you want to do with my data. Or just saying, well, it's my property, good luck. Even if you are required to make the data available by the journal that you published, and people say, nah, we'll not do it. So basically this means that in many cases it means data available upon request is just not available. So you could just not make the statement and not much would change. And this brings us again to what we discussed yesterday, and I think the day before even, it's that data should be fair. It should be findable, accessible, interoperable, and reusable. And if you just put a statement in your paper and don't deposit the data anywhere, that's like as far from it as it can get. So basically the main takeaway here is please make your data available in repositories. And there's like a ton of different data repositories that you can use for publishing your data. And here's just a small collection of them. We heard about Zenodo, Figshare, and the Open Science Framework. And there are lots of repositories which are domain specific. So if you are doing neuroscience, then NeuroVault and OpenNeuro might be your databases. If you are in biology, the protein data bank might be yours. The geosciences have their own databases. And I think it's generally a good idea to use like your domain specific repositories, because they are set up for having all the metadata and making it accessible. They have the APIs your domain wants to use. So there is a lot of them, and it's hard to choose sometimes. And how to choose? Well, it depends on your data types, on the data size, because not every repository accepts whatever data sizes. Well, if you have like terabytes of sequencing data, the sequencing databases that biologists use will happily accept these. Open Science Framework will probably maybe accept it, no one knows. And other ones like Figshare say like, oh, it's 5 gigabytes that you can upload, so good luck. And it depends on your academic field. And how to choose? What I find is that F1000 Research has really pretty good guidelines, because they make data, they actually say your data needs to be in a repository. You can't just say we will make it available upon request. And their website basically gives you this whole list of which data type do you have? Do you have sequencing data? These are the databases you might want to use. You have neuroimaging data. These are the databases for you. You have software code. This is the databases you can use for that. So you can basically just go to this website, look it up, and then they will give you a list of what you can use and what you should use. And just putting data in a repository is the first step, but then what is there's no fitting repository? That might also be your chance to make your own one. And that I will talk a bit about this later, about how we started our own repository. But in principle, it is a good idea that if no one else wants to do it, might be your chance to become like a great reproducible researcher and get fame and credit for doing so. That's basically how the OpenNeuro and the NeuroVault project started. There was just no way for people to deposit it in like a usable way. And just like some postdoc decided to make their own database. And that's now basically their main project they are working on. So let's say you put it now into a repository, and then they ask you to pick a license. And there's like more licenses than anyone can imagine or ones to think about. And it's really confusing, and people always struggle to find out what you should use. And that's, I think, what partially leads to people making up their own licenses and say, oh, you can use it for non-profit uses or for academic use. So it's really hard to decide which one to use and what the limitations on data should be. And there is some empirical evidence on what you should do, actually. This was done by reusabledata.org, a collaboration of many academics who looked at 60, 70, whatever databases and the licenses they put on the data in these databases. And you see that 40% use a custom license, which basically is terrible because it means you need to actually read these licenses. You can't have like an easy expectation of what the limitations for the data are. And if we look at like more liberal licenses like the Creative Commons Zero or the MIT license, this is like a really, really tiny fraction of what people use. And this is especially problematic once you start thinking about wanting to remix data sources. So if you want to have data from more than one repository, from one more data set, then you have like a really terrible problem, because now you want to somehow find out how these data sources are compatible and whether you're even allowed to use these data. And they looked into this in this paper for looking at these 60 whatever data sources. And each of the nodes here on the circle is a single database, and each edge is whether they are compatible with each other or not. And ideally, this should be like a fully connected graph if you think you should remix everything. And it turns out that's far from true. So there's like a huge gap, especially in the lower left bottom, where you just databases can connect to one or two other ones. And if they really connect well, then it's only because you see these like slightly green nodes. These are the ones that use super liberal licenses, which let's say you can do whatever you want. So they are compatible with everyone else, but not everyone else can play nicely with other ones. So what to do? You should make your data as open as possible, I would say. So if you publish it and you want people to use your data, put like a really liberal license on it. And for data, this usually means applying the CC0 license. Well, it's not really a license. It's basically you donate your data into the public domain. This says it's a declaration that you waive all of your rights. You say, as far as possible by the law I'm currently operating under, I waive all my rights and you can do whatever you want with my data. So if you do this, everyone can now use the data, remix it, reuse it, and there's no limitations to it. So basically, if you go CC0, you are the hero of data sharing. And then it's the issue of how you should not publish data. And this is like the most extreme example of reproducibility gone wrong. That was 2 years ago. So someone made like their own preprint on online dating behavior. They scraped OkCupid. 70,000 users had their data then published because the person was like, oh, I want to be really reproducible. And they just scraped OkCupid, like all the information, all the questions about how people date and so on, and decided to put it like under CC0 on the Open Science Framework. And people were kind of unhappy with it, and the Open Science Framework was, first, well, it's like an academic publication, it's okay, and then there was like this huge outcry on the internet about like, this is really private information, it should not be there. So this is really, really bad. To get an idea of what published, so they published of these 70,000 people their usernames, their sexual orientation, whatever their preferences are. And this included like all of these different things that people don't want to have made public on the internet, especially not in an academic repository that basically says, we will store this for all eternity, because it's like now part of the academic record. So the problem here is that it's full of sensitive personal information. The person who did this was just one single individual who was doing, I think, even just an undergrad degree somewhere in Denmark, who just was like, oh, I will like do a fun science project in my spare time, and so no ethics review was applied at all. Of course, no one was asked of these 70,000 people. This guy just made like its own OkCupid profile and then answered all the questions to be able to scrape as much data as possible. And the data was published like in full. So there was not even like any idea of trying to anonymize it or de-identify the data. And there's two problems here. It's first how the data was shared, and also it's how the data was acquired in the end. And let's start about the sharing and publishing of data that should just not be made public. And one approach is to keep it as close as necessary. Is unfortunately it goes back to making data available upon request at the end of the day. And here's an example from Neuroscience again that was published along with Kirsty Whittaker, one of the Mozilla Science Fellows, and basically they had said, okay, we uploaded all of our data into the Cambridge data repository. Here's the DOI. You will know this data will be forever at this link, but it's password protected. You can't get access to the data unless you send us an email and explain why you want to have access to the data, how you will use it, and so on, because our participants did not give informed consent to having their data made publicly available. And that's one way to keep this data somehow available, and people know that it's deposited somewhere and it can't just disappear, because data available upon request can often mean it's somewhere on a person's hard drive and the hard drive dies, the person moves 3 times, loses the hard drive, all these things happen, and I know people who have lost their data like this. So if you put it somewhere, you know it will be there, people can always find it, but maybe they need to have the password first. The second, more formalized access restriction mode can be used using software at the end of the day. And here's a really nice example of what Sage Bionetworks in the US is doing with their Synapse tool. And if you sign up, so it's like a data repository, and if you sign up, you have to pledge basically to their awareness and ethics pledge, which means you will act ethically and responsibly, you will protect and respect data of the participants, you will not hack the system, you will share the content only with other people who have like signed this thing. You will not just like then download the data and now put it on open science framework. And all of these things is like the first step if you sign up. And just signing up is not good enough, because they even make take a test. So they have like a multiple choice test, as you all have taken in the past as well. And they basically say you first need to read all of our governance documents on what you need to do and what you are able to do with the data. And to see that you've actually read it, you need to take a test. And I think it's like 15 different randomly chosen questions from like their set of questions for signing up. And if you pass, you can actually then start accessing data. And if not, well, you can try again, but then maybe read the documents again, because you will get 15 different questions this time. And to make it even more official, they make you actually print out and sign the oath that you will do good things. It's basically more of a social thing, but it's like if you've gone through the thing, you've read it, you've signed it with your name and like sent it back via mail to them, you have at least like understood the things you cannot do. So you will not re-identify people. People in this database can potentially be re-identified because it's all genetic data, but you should not do it, and you have said you won't. You will not share the data, you will not use the data for advertisements, you will keep the data secure, and so on. But it's a pretty automated process at the same time. So basically, all except for sending this via mail can be done online. You can get your account just by like doing the multiple choice thing, and if you pass, you can start accessing data that's not super sensitive at least. And I think that's like a good way if you have like personal data, especially in biomedicine, that you want to put somewhere. That's like a really nice way to do it in a way that you can say, well, it's published here. Here's even like the identifier that you can use for accessing it, but you need to be like the qualified researcher in the system. And the second issue that was with the OkCupid data publishing leak, however you want to call it, was how the data was acquired. And the data acquisition these days often goes through just websites at the end of the day. Either you just scrape OkCupid, or if you get access to Facebook by having friends there or whatever, you can do your research project and you just publish stuff. And this is another example of where data from like a social media, or I think in this case another dating website, was used where they trained this AI to predict whether someone is gay or not based on their faces. And again, no one was asked whether they would like to participate. It was just people scraping the data from the web, doing the research, and then publishing the results. I think in this case, at least without publishing the data, but nevertheless the people felt very offended about having been used in like a research project they never would have consented to otherwise. So, and this leads then also to like all sorts of like different problems downstream. So if we do research on people's data without them consenting to it, this is ultimately where we can end up. So people's data is used for this stuff, and everyone is very unhappy, and who sees what 2020 will bring, right? So the alternative to this is doing participant-centered or participant-led research. And that's what I'm working on these days full-time somehow. And the idea here is basically to flip the table and say we are not just scraping data, but we ask people to consent, to contribute. And then we put the people itself in the center, and the researchers can come to them. And it's not only exploiting them, but it's like a two-way conversation of the participants and the researchers. And this is not a super new thing. It's been around for a really long while that people are just doing stuff on their own, especially when it comes to medicine. Often patients are just doing science on their own because they become the experts, especially in some fields where medicine itself doesn't have a really good idea yet. And the benefits here is, first of all, you can involve your participants in designing your project study, and you can actually check whether they think this is like a good study or not. And people can actually give consent to what you are doing. So this huge ethical issue of just scraping the data and hoping no one complains just vanishes overnight, basically. And I'm working on 2 projects which are implementing this. The first is OpenSNP, the second is OpenHumans, and I'll talk a bit about both and how we've tried to tackle this in generating open data, or at least participant-centered data sharing. So OpenSNP is just for genetic data at large, and the idea is that 10 to 17 million people have already got their genome analyzed one way or another through commercial tests like 23andMe, Ancestry DNA, and so on. And people want to share this data at the end of the day, at least some of them. And you can see the growth curve. So like in a couple of years, we'll have like 100 million genome data sets that can just be used in principle, but which are stored in commercial companies who again do the same thing. They just do science on it, but like researchers outside in academia can't really profit from it. So I got my own genome analyzed in 2011 and wanted to put it somewhere on the internet. There was like 2 or 3 more people who put it just on GitHub, because it's code after all, right? But it's not useful because it's not really fair. It's not findable, accessible, yes, but interoperable, yeah, if you want to somehow just clone Git repositories, reusable, limited, because if it's not findable, it's like all a bit in vain. So we decided to make our own data repository. Back then I was doing like an undergrad degree or my master's degree in ecology and evolution, knew like a tiny bit of coding myself just for fun, and decided with a friend, let's do this. And our idea was to make it completely open data, so we want to put all this data into the public domain for 2 reasons. One is the whole interoperability issue, that you can make it, basically you can use it for everything. The other reason why we decided to do this was largely security related, because 2 people who have biology degrees probably don't want to run super secure infrastructure, or can't. And if we promise people we keep their data secure, that's just a terrible recipe for disaster. So we decided, well, we promise you there's like no security, no safety, the data is in the public domain, you lose all rights if you publish the data. That way we can claim that there's no risk of data leakage at the end of the day. Then, of course, it's completely open source, and it's crowdsourced in the sense that people donate their data. So everyone who has done any genetic testing can just publish the data there. And by now we're even crowdfunded, so it's just run basically on people's donations. And since 2011, we have like 7,000 people signed up and 4,500 data sets published in the public domain, which makes it the largest personal genomics data resource in the whole world, I think. So that's basically just 2 people who have really no idea of programming, at least not at the time, doing something, and it grows. So if you think about doing your public data repository, it's not super hard if 2 biologists can do it, I would say. And yeah, in addition to this, people also annotate these data sets with their phenotypic data. This can be hair color, eye color, height, whether you use Vim or Emacs, because all of these are crowdsourced as well. So people actually make up new phenotypes, and people ask, well, what's your political orientation? What's your favorite text editor? People answer it, and now you can do the genetics of Vim versus Emacs. So I don't know whether people found anything there. And this data is actively used already in any case. So this is an example of how it's used directly in like the whole citizen science idea that Luke talked about on the first evening. This is like an email I got by one person who's a medical doctor in the UK, and he just goes through every single data set, analyzes it using his own written tools somehow, because he just is interested in human genetics, and sends people back like a report of what he found in their genome. So for me, he wrote like, yeah, your results show your European background very well. Well, no surprise if you look at me somehow, and it's like not super interesting. He said, oh, you're a carrier for one of these variations, which have been associated with a heart disease, but the evidence is poor, so don't worry about it. And last but not least, basically what it says, it's your parents aren't closely related. That's what he found out by looking into my genome, and he's basically sending emails like these to every single person who publishes their data. And it's like the most direct participant-driven science that you can somehow get. People just publish their data as an individual, someone else takes it, who's just like an interested hobbyist at the end of the day, gets back to people. And the second interesting or fun example is a couple of years ago they found a skeleton in a car park under, I think, Leicester, which turned out to be the skeleton of Richard III. And this genome was sequenced as well, or at least partially, and now people compare like our 4,500 public data sets to see which of our users are related to Richard III. And then you can also use it for more traditional research. And this was done at the EPFL, actually, de-anonymizing genomic databases, where they looked into basically using our data as the source to look into whether you can re-identify people based on their traits. So if you look at someone and you see what's their height, their eye color, hair color, now you have like some phenotypes which you can try to pick out which is the most likely genetic data set in the database, and then you can use this to re-infer all the other things. So that's like a really cool application. And it basically also highlights why the whole differential privacy is really, really hard, because like with very limited information, you can always like somehow get much more out. Here's another example of someone doing this beginner's guide to genetics hacking. It's like some software engineer who was just interested into genetics and used like the public data to play around with it and educate himself. Then like people write theses on it for machine learning, for example. Here someone used the data set of the genetic data and the phenotypes. And she was interested in like finding out whether machine learning works on this data and how well. I think this was a master's thesis. And yeah, we also did this fun project with Crowd AI at the EPFL where we did this prediction of whether people can find out the height based on the genetic data. And it was like this competition. People were submitting lots and lots of different algorithms and how they trained it. So like 123 people, 1,200 submissions. And I think what I like most about this, which just demonstrates how hard biology is, the winning entry did not really use machine learning, but expert knowledge. So this data is used a lot, and it's really cool for many things. So people give consent to their data sharing. They're willing to donate their personal data, and it's already being used, which is really great. At the same time, one has to say this completely public domain approach has some problems as well, or like some limitations. So there's no grades of sharing. It's like a binary decision. Are you willing to make a genome publicly available, yes or no? If yes, it's there. If not, it's just absent. This makes consent a one-time decision, so you can't redecide really. I mean, you can delete the data, but then it's out there. It's already been licensed once. Who knows what happens? And in the end, it's a complete loss of control over your own data. And this is where Open Humans, what I'm working on now, takes a different approach of a more granular consent idea, that people can consent to different things. And how it works, it again puts the person in the center with their Open Humans account in this case. And what you can then do is anyone can make a project on Open Humans, and the project can basically ask people to get access to data, to upload data. And it's all very standard web technology at the end of the day. So it's like you make a project, and then you get into touch with your potential user, and then you use OAuth to ask people, would you like to give me permissions for different things? This can be uploading files into your account, whether I can see your username or whether you want to have just a pseudonym, whether people can message you, all of this. And if the person agrees, Project A now can upload data into this person's account. So if you have like some website that generates data, this can be stored into a person's Open Humans account so that they have like one big data repository in their own account there to have control over. And then you can have the next project that someone else does, and this says, okay, again, you get into touch, and I would like to upload files into your account, and also, can I get access to the data that Project A has deposited? And that way you now can, basically the person can decide whether Project A data should be shared more widely or not. And again, if they do, it ends up in this account. And then, of course, you can also make the data parasite project that doesn't deposit any data, that just takes data from different projects, and can use this for scientific research. And these projects can basically be done by anyone. That's the nice thing again. It's like participatory in the sense that you can make a project right now. You don't need to be an academic necessarily. It can be individuals who just want to do research on data, make their own project, ask participants to share their data. And it's all in a very consent-friendly framework at the end of the day. So to just give some examples of how that works in practice, like one example that's running right now is academic research on activity trackers. I don't know, I guess many of you are wearing some kind of step count thing or have a phone that does step counts for you. So what's happening is people put all of these data into their Open Humans account. May it be like the Apple Health Kit, Fitbit, and so on. And if they connect it, they can now share the data. And right now we have like at NYU a study with Rumi Chunara, it's called Keeping Pace, where people basically donate their data to find out how human behavior in terms of activity varies between seasons. It's basically, are you becoming less active if the weather is bad, give or take. But this is then completely enabled in a framework where Rumi is sure that all the data she's getting access to has been consented to by the individuals. Unlike to just go to Fitbit and try to scrape it or ask Fitbit, could you be willing to give me all the data without asking anyone? Rumi can be sure that this data set has been collected like an ethical, sound way. A different example that's more citizens-based is this genome exploration tools that we have. People put their genetic data into Open Humans as well, and there's tools written by individuals who are not academic to somehow annotate data and to analyze it and give people predictions as well. And then we come to like the coolest example so far, which is the diabetes community on Open Humans. And diabetes is really terrible for people because it means lifelong managing your disease. And it's really, really a lot of work. And at the same time, at least the community itself feels academic research isn't doing a great job in helping them out. That's why they have like the "We Are Not Waiting" hashtag, and they are basically now do-it-yourself biology biohackers who try to find out how to help themselves. And this is Dana Lewis, one of our project leads on Open Humans, with her self-built artificial pancreas. So she is suffering from diabetes, and the issue she has is that usually there's, I think there's like a 50% lifetime chance of dying in your sleep, because basically your blood sugar just drops. You don't notice it and you just die away while you sleep and you don't wake up. And the issue is she has like this continuous glucose monitor, which in principle should warn her about it and wake her up. But she sleeps very, very deeply and is not easily waking up, and the tool was not making an alarm loud enough for her to actually figure out that she should maybe wake up and get some insulin. So she figured out that you can actually reverse engineer the Bluetooth standard, which is not encrypted, and then actually just like plugged into the Bluetooth signal of a glucose monitor to figure out when the blood sugar level drops too much to like send a louder alarm, which was the first step. And then she was like, well, but I also have this insulin pump, which also can be connected to. Why can't I close this loop and basically once the blood sugar level drops and I get a notification, automatically pump more insulin? And that's basically what she did, and that's what she's presenting here. It's the artificial pancreas she built. So she has her glucose monitor here, she has like the small microcontroller she programmed herself with the algorithm and the insulin pump for completely closing the loop. And she made it available completely open source, largely for, I would say, regulatory reasons, less for, at least in the beginning, maybe less for the reasons that it's like the right thing to do. But if you do like stuff like this, in the US it's the FDA, the Food and Drug Administration, who needs to sign off on your medical device. So you can't really somehow market it. But if you just make it open source and put the schematics on GitHub or whatever on the web and say you can build your own, everyone can build their own tool, and that's completely okay. So now a couple of, I think, 100 people are using this thing, who've built it themselves at home and basically manage their glucose levels like this. And they now want to do research on it. And they have this data commons where basically people can donate their data and the community itself decides who can get access to this data set. And this is growing so well by now that Dana, who I think has like an undergrad degree in marketing, so not science related at all, is PI on her own grant. She's now doing research on diabetes as a PI despite having no academic credentials that would be traditionally allowed to perform this. And yeah, this is all managed through Open Humans by now. So people put their glucose data through these data transfer tools into Open Humans, and then people have like this data commons that they can sign up on. And this data commons itself is like a steering committee which decides which researchers get access to the data. To give some idea of how many people are doing this at all, it's like 5,600 whatever, and 2,200 have shared at least a single data set. So there's 15,000 data files already on Open Humans that you can ask people to give you access to. And 26 projects are already doing this right now. And our data sources are really diverse right now. So we have like genetic data, the activity tracking data. You can upload your complete Twitter archive. If you have like tons of tweets, you can analyze those. I think next week, hopefully, there will be the Spotify data import. So if you have like your Spotify listening history and want to analyze these or share these with other people, you can do this. So there's lots of different things, and as it's completely modular and just API-based, any one of you can do it as well. So if you are in neuroscience and you want to allow people to upload MRI images, you can make your own project. People can donate their MRI images to you. And one thing that's really nice once you have all your data in your account, it's more the reproducibility on a very small scale, is that you can now use Jupyter notebooks to analyze your personal data and share these analyses with people, which is very interesting for like the whole quantified self community. And the personal data notebooks, basically what it means is just you have like a Jupyter hub, you log in with your Open Humans account, And then you can just open a notebook. And in this notebook, you already have all the access credentials for getting access to your own personal data. And as this is all standardized, if you share the notebook, other people can use the same notebook, don't have to share anything because it's just your data. So yeah, this is then the list of all the data files that you will see in like a person's account, and now you can open the files, analyze them, and so on. And the fun thing is that you can then start correlating different data sources. So once people have not only genetic data, but also activity tracking data, productivity data, and so on, then you can do stuff like this. Do my step counts drop when it's cold or rainy outside? So the stuff that Rumi is doing, people can now do on like the N of 1 basis to just use their GPS tracks and their activity tracking tracks and see whether there's any correlation. And for me, there seems to be at least some, I guess. More steps if it's warmer. Or does my daily workload influence how much I walk? This is in 2017 when I was finishing my PhD. So the more hours I spent in front of my computer working, the less I moved. And if you look at it, you can also correlate it with like weight, which raises at the same time, of course, because that's how you finish a PhD. And the benefit of this data aggregation is that it's the reproducible N of 1 experiment. So if you put your data out there in a framework that allows you to do analysis, you can do these experiments of N of 1, and you can allow people to run them on their own data to see whether it's like a larger effect or not.
Sorry.
Yeah.
What do you mean by a reproducible N of 1 experiment?
Well, it now means that you can basically just share your notebook with other people, and they can run it on their own data right away. So it's maybe more the replicable N of 1 experiment in the terminology of the thing.
N of 1 in the sense that
you have like one. Yeah.
Okay.
And this is how it looks like. So, are we willing to try a live demo? Is the question. So people can publish their data, their Jupyter notebooks really easy just by a single click from the notebook itself. There's like a small plugin I've written into this thing that you can just say, share the notebook. And then it ends up on this website here, and you can see what the different data sources are you can filter for, and so on. Then you can figure out whichever data set or like analysis notebook looks interesting to you. For example, like people upload their Google search history into their Open Humans account and analyze it there. And then you can see, okay, this is how the notebook would look like and everything, and that's all the code. And also it gives you like the plots of like the other person has done. So this is the plot of the person who published the notebook. And if you say you want to run it on your own data, all you have to basically say is open in the personal data notebooks. And if you do this, it will just open the Jupyter notebook right away. And once it loads, it should give the same notebook, and I can run it right away on my own personal Google Search Archive, which I would be very happy to do now, but I do know my Google Search Archive is like 28 megabytes, and parsing it takes forever because the Google Search data comes in HTML, and Beautiful Soup is just very, very slow. So that's how like the original notebook looked like, and if I then run it on my own data, this is how it looks like. And actually, if you compare it, like the top is the Google search data of my wife. She's a neuroscientist, that's why she's using MATLAB and is interested in the PsychoPy stuff and so on. And for me, you see, I don't know, it goes back to 2011, I guess, when I started learning first Rails, then R, then Python. So that's really fun. This way you can even basically do data analysis on really sensitive data, because I guess most people are not willing to just like upload their complete Google search history publicly and have it reused. But you can make notebooks to ask people to look at their own data and basically send you the results. And so to sum it up, first of all, generalizable findings rely on sharing data. So if we don't share data as a research community, it's really, really hard for us to get forward anywhere. And there's already plenty of databases for sharing. It's just a matter of finding the right one and making sure it's annotated with all the metadata that you need. And I think yesterday there's already good work on how to annotate this. And you should always share data with a license that allows the reuse and remixing of data, but then at the same time, data sharing can be really hard if you have human data. And I don't know how many of you are affected by this, but if you do human research, it's really, really terrible. But yeah, be as open as possible and as close as necessary. I think that's the main takeaway. So if you have a chance to publicly share, do it. If not, think about how you can make it not publicly shared, but shared in a way that people can still profit from it. And yeah, think about how you collect and distribute your data. And yeah, doing constant less scraping of data from people is really not cool, especially not in this day and age where people have so much private data on the internet that somehow might be publicly accessible, or if you make a fake account somewhere, but please don't do it. And with that, I would like to come to and just thank a couple of people. Tim, who is not only the binder expert, also helped us setting up the whole Jupyter Hub on OpenHumans, so without him, this wouldn't work. John Wilbanks is the guy who's working very actively at these whole consent issues at Sage Bionetworks. Philip up there is the guy who started OpenSNP with me. Matt Ball is working on OpenHumans. And Kirsty Whittaker is the one who was like the nice matrix of reproducibility, replicability. That's her original idea. And I think now it's time for some questions.